Let's first look at coefficient of variation. It is a standardized measure of dispersion about the expected value that shows the risk per unit of return. And it is because it's defined as standard deviation divided by expected return. So we're measuring risk per return. Okay? We always want a lower risk and a higher return. So we want a lower numerator and a higher denominator. So we would prefer a lower CV. Okay, the lower, the better. If we look at this graph here, if we have asset A and B, we see that the expected return of B is actually higher than the expected return of A. And they have the same normal distribution, same, you can see the degree of how these two lines are spread out are similar. So we say their standard deviation is similar, okay? Even though expected return of A is smaller than B, but the standard deviation of A equals to B. Okay, so if we calculate CV, because CV is standard deviation divided by expected return, so CV of A will be larger than CV of B. Okay, and we prefer a lower CV, so B is actually better. Okay, B has the same risk but higher return. B is better. A is riskier because of larger probability of losses. In other words, the same amount of risk for smaller returns. Okay, A has the same risk but smaller returns, so A is riskier, and A has a higher CV. Okay, so CV is actually a better measure than standard deviation, but because it incorporates risk and return. Even though we say CV, it's also a measure of standalone risk. So if we go for those five investments we had in last class, in the last video, we can calculate CV based on the return standard deviation. And we can see that the CV for high tech is that and market is similar. US rubber has a higher CV because it has a lower return with higher risk. Treasury bill has zero CV, and collectibles has the highest CV because it has lowest return, highest risk. So high tech, despite having the highest standard deviation of returns, has a relatively average CV because it has a high return as well. And collectibles has the highest degree of risk per unit of return. Okay, highest CVs. It's not a good choice. Question: standard deviation is a better measure of risk than the coefficient of variation if the expected returns of the securities being compared differ significantly. This is false. Coefficient variation is actually better than standard deviation, okay, because it takes into consideration both risk and return. Okay, so far we've talked about the risk and return measures for a single stock. For return, we can calculate expected return. And for risk, we can either use standard deviation or coefficient variation. And CV is actually better than standard deviation. Okay, next, we're going to talk about how to calculate risk and return for a portfolio. And portfolio is just a grouping of financial assets, such as stocks, bonds, and cash equivalents, as well as their funds counterparts, including mutual, exchange traded, and closed funds. Okay, so it's a combination of different financial assets instead of a single assets. So that's a portfolio. For example, if we have a two-stock portfolio created with 50,000 invested equally in both high tech and tech collectibles with equal weights, we can calculate the portfolio's expected return as weighted average of the returns of the portfolio's component assets. Okay, so the RP, portfolio expected return, equals the weights for each asset, WI, or asset I, multiplied by RI, the expected return of each asset I, add them up. So here, if we want to know the return of this two-stock portfolio, we have to use the weight for both high-tech and collectible multiplied by the expected return of high-tech and collectible and add them up. And we already know that these two stocks are equally weighted, so the two weights are 50 and 50%. And the expected return of these two stocks are already collected in the last class. Okay, it's also in the graph here. It's 12.4 and 1% for each of them. So we just use these two numbers, multiply by 50%, add them up. We have 6.7% as our portfolio return here. Okay, weighted average return of each asset is the portfolio return. An alternative method to calculate expected return is to use the return for high-tech and collectible in each economy, multiplied by the probability for each economy. So we know, so the method we just used is to use high-tech return and collectible returns in 5 scenarios, multiplied by the probability, so we know the expected return of high-tech and collectible, and then take the weighted average, so we have 6.7%. An alternative way is to calculate this portfolio return in each scenario first by taking the weighted average of the 2 stocks in each scenario, and then use these 5 returns multiplied by the 5 probability to get the expected return of the portfolio. Okay, so R hat of the portfolio equals the return of the portfolio in each scenario multiplied by the probability. Okay, so step 1, we have to calculate the portfolio return in each economy. In recession, it's going to be 50% multiplied by the high-tech return, negative 27%, plus 50% multiplied by the return of collectibles, 27%. So it's 0%. Weighted average of the portfolio return is 0% in each recession. When economy is below average, we can again use 50% multiplied by the 2 returns of the 2 assets. So we have 3%. And we do this for all the scenarios. Okay, so we have all the returns in each scenario. And then we use the 5 returns multiplied by the 5 probabilities, 0.1, 0.2, 0.4, 0.2, 0.1. Add them up. So we have 6.7%. Okay, so this is another way to solve for expected return. When we want to calculate standard deviation, it's a little bit trickier and requires a new probability of distribution for the portfolio returns be constructed. So for standard deviation, we have to use the portfolio return in each scenario minus the expected return of the portfolio, square it, multiplied by the probability, take square root. So we have to calculate this last column here by taking the weighted average of the 2 assets for 5 times, and then use these 5 returns minus 6.7% square, and then multiply by probability, and then take the square root. Okay, so we use the 5 returns minus 6.7% square, multiply by the 5 probabilities, take the square root. So we have standard deviation. Another way is to calculate the last column there, the return of portfolio in each economy first, multiply by 100 and input it as x in the data function. And then use probability, multiply by 100, input as y in the data function. And then we go to stat function, x becomes 6.7, sigma becomes 3.44%. And then the CV for this question is standard deviation divided by expected return. And that's 0.5134. Okay, so let me show you how I can use calculator to solve for portfolio expected return and standard deviation. Step 1 is still getting this last column by using 50% multiplied by high-tech and collectible returns in each scenario and get the last column here. The second step is to go to second data. Okay, x1 becomes 0, enter, because that's the portfolio return in the first scenario. The probability would become 10. That's going to be 0.1 multiplied by 100, enter. x2 is going to be 3%, 3% multiplied by 100, enter. Down button, y2 is going to become 20, enter. x3, 7.5, enter. y3, 40, enter. x4, 9.5, y4, 20. x5, 12, y5, 10. Second stat, okay, one variable, down button, n is 100, x bar is 6.7%, standard deviation is 3.4438%. Okay, and then we use this 3, we quit out the function 3, we use this, excuse me, 0.0344 minus divided by 0.067. Okay, so that's how we get this 0.5134. Okay, that's portfolio return and risk. And the portfolio risk here we had was 3.44% as standard deviation. It is much lower than the standard deviation of each stock. High tech is 0.2 and collectible is 0.132. Okay, so the portfolio is less riskier than any of the stock in the portfolio. And this standard deviation is also lower than the weighted average of the two stocks standard deviation, which is 16.6%. So the portfolio provides the average return of component stocks, but lower the average risk because negative correlation between the stocks. Okay, so this portfolio is actually gives us the average return of the stock, but the risk is lower than the average of the two stocks return. Okay, because the two stocks move in opposite directions, with negative correlation. So it actually reduces risk for us when we form this portfolio. Okay, we will talk about the risk diversification of portfolio later again. General comments about risk. Sigma equals 35% for an average stock. On average, the correlation coefficient between the returns of two randomly selected stocks is about 0.3. Okay, so these are the average risk for a stock and average correlation between two stocks in the market. Most stocks are positively, though not perfectly correlated with the market, row between 0 and 1. Combining stocks in the portfolio generally lowers risk. Okay, so using portfolio is a very good way to do risk diversification. Let's look at 3 typical scenarios here. When we have stock correlation that is perfectly negative, perfectly positive, or partial, there will be 3 different effects on the risk diversification. When the returns distribution for when the two stocks are having perfectly negatively correlation, we can see the return distributions in this graph here. So if the two stocks are perfectly negatively correlated, the row is -1, meaning the return of the stocks move in the same degree but in opposite direction. Okay, for example, we have W and M here. You can see they have exactly the opposite return. Okay, they move in the W shape and M shape, so the same degree but different option, different direction. Okay, in this case, the expected return of these two stocks, W and M, would be 15%. Okay, very stable, and the risk of the two stocks are totally diversified away. Okay, if we look at these stocks separately, each of them have risk. Okay, they still go up and down around the expected return. But when we have the portfolio WM consists of these two stocks, there's no risk at all, because when M, for example, when W here is of a 30% return, M is of 0% return. So when you hold this portfolio of these two, the average of these two returns is still 15%. So the portfolio always has this expected return of 15%. Okay. So when W has a high return, M would have a lower return. When W has a lower return, M has a higher return, and always their average will be all the same. So two perfectly negatively correlated stocks, when they move in opposite ways, it's the best case of risk diversification. Okay, when they are correlated at -1, all the risk goes away. A data extreme case is when these two stocks are positively correlated, perfectly positively correlated with a row with 1. So we can look at stock M and M prime. They are similar to two similar stocks. They move in the same way, same direction, same degree. So the portfolio MM would have the same risk as the single stock. No risk is diversified away in this case. Okay, this is the worst case. A middle case is when we have partial correlation, when rho is between -1 and 1. For example, typically in the market is any two stocks are correlated at rho of 0.35. So when W moves, Y moves a little bit similar, but different. Okay, so the portfolio WY does have less risk. Okay, risk is diversified away partially. Okay, so the first best case and second worst case is hard to see in the market, but the third case here, partial diversification of risk, is very common in the market. So we like portfolio. We like to form portfolios instead of holding single stock because we can minimize risk. So we like to, if we create a portfolio and begin with one single stock, but add randomly selected stock to the portfolio, we would see that the standard deviation for the portfolio decreases as stocks are added because they would not be perfectly correlated with the existing portfolio. Okay, so as long as it's not like a same stock added in, we always have the partial correlation and the partial risk diversification. Risk of the portfolio decreases when we add a random stock. The expected return of the portfolio would remain relatively constant. Eventually, the diversification benefits of adding more stocks dissipates about after 10 stocks. And for large stock portfolios, standard deviation tends to converge to 20%. So here is a graph showing the diversification effect of a portfolio. X shows the number of stocks in the portfolio from 0 to 2000, from actually 1 to 2000, from one stock to many stocks. Y shows a standard deviation, the portfolio risk. So when we have one single stock, a typical stock standard deviation is 35%. And we add a stock, so we have two stocks in the portfolio, the standard deviation typically goes down to around 30%. Okay, and then when we add more and more, this risk goes down and down and down until we add 10 stocks. Until after 10 stocks, whenever we add a new stock, the decrease in the portfolio risk is becoming smaller and smaller. And no matter how many stocks we add in the end, the stock portfolio converges to a standard deviation of this market standard deviation, 20.4%. Okay, we cannot reduce the risk by adding more stock anymore. So we say that this upper part of the first, we say that the portfolio risk, okay, it's the portfolio's total risk. It declines as stocks are added. And we say that the upper part of this graph, above this 20.4% line, it's the portfolio's diversifiable risk. Okay, the upper part could be diversified away, could be reduced by adding more stocks. So we say it's the portfolio's diversifiable risk. And the bottom part, okay, the stable part of 20.4% is portfolio's market risk. It remains constant. Okay, this bottom part, market risk, does not go away no matter how many stocks you have. Even though you hold hold all the stocks in the market, you still have this market risk. So we say the standalone risk of the portfolio equals market risk, okay, the bottom part, plus diversifiable risk, the upper part. Market risk cannot be diversified away by adding more stocks, but diversifiable risk can. Okay, market risk is the portion of a security's standalone risk that cannot be eliminated through diversification, measured by beta, and we're going to discuss it in class 3. Diversifiable risk is the portion of a security's standalone risk that can be eliminated through proper diversification. The upper part, it can go away when we add more stocks. When an investor chooses to hold a one-stock portfolio, doesn't diversify, would the investor be compensated for the extra risk they bear? No. Standalone risk is not important to a well-diversified investor. Rational, risk-averse investors are concerned with standard deviation of portfolio, which is based upon market risk. There can be only one price for a given security, which is the market return. No compensation should be earned by holding unnecessary diversifiable risk. Okay, so if you don't diversify, if you just hold one single stock, you still have to you still have the return that's determined by the market. And when most people in the market are holding a portfolio, that's the return of the stock is going to be determined by the return of the stock when it's held in a portfolio. 2 further questions. Why would the investor ever hold one or a few stocks? Why not hold a market portfolio consisting of all stocks? It's due to high administrative costs and commissions for single investors, but in reality, for larger investment corporations or such as the different funds, they typically hold a portfolio. Superior analysis. More information is incorporated into the stock valuation process. How should we measure stocks risk in a world where most people hold portfolios? Next section, beta. Practice. Which of the following statement is correct? Option A, an investor can eliminate virtually all standalone risk if he or she holds a very large and well-diversified portfolio of stocks. This is not true because an investor cannot eliminate virtually all standalone risk. Okay, it can only eliminate diversifiable risk, but not the market risk. Okay, not all of standalone risk, but just part of it could be diversified away. Option B, the higher correlation between the stocks in the portfolio, the lower the risk in the portfolio. That's not correct. Okay, the higher the correlation, the higher the risk. Remember when rho is 1, the extreme case, when the rho differs from -1 to 1, when rho is 1, it's similar to 2 similar stocks combined in a portfolio. It's the worst risk diversification. It has the highest risk. And -1, when the correlation is lower, actually it's better. There's lower risk. So lower rho, lower risk. Lower correlation, lower risk. Higher correlation, higher risk. Option C. It's impossible to have a situation where the market risk of a single stock is less than that of a portfolio that includes the stock. It's not correct. Okay, market risk of any stock or any portfolio should be the same. It's just that about 20%. Option D. Once the portfolio has about 40 stocks, adding additional stocks will not reduce its risk by even a small amount. It's not correct. Adding additional stocks will still reduce its risk by just a small amount. Option E, this is correct. An investor can eliminate virtually all diversifiable risk if he or she holds a very large, well-diversified portfolio. That's correct. The investor would only hold market risk. Okay, that's all for class 2. We will discuss class 3 in the next video.